delegates. The type that you've probably run more often than any other, by far, by a lot, is the asynchronous event. Does everyone know the difference between events and delegates? I need a refresher. Well, you can read the slide. Events are publishers and set up a publishing subscribing mechanism. An event is a broker for delegates. An event is a place where delegates can go to hang out together. Okay? Events give you a way of calling multiple delegates all at once. And that's pretty much what it is. Events have been part of the .NET framework since 1.0. Asynchronous event handlers as a major part of the paradigm for writing asynchronous code really started in .NET 2.0. How many of you were programming before .NET 2.0? How many programmed in .NET 1 some flavor of? Yeah. Okay. So you remember how excited you were when asynchronous delegates came in .NET 2.0? Back in 03, was it? Or, no, it was 05. 05. I was thrilled. This is what most UI, the reason I'm saying most people have used this is because this is how Windows Forms, Silverlight, WPF, they all use some variation, and also ASP.NET Web Forms, they all use some variation or other of the event, of the asynchronous event model. In .NET 2.0, there's a class introduced called background worker. You'll see in a minute. So, what you do with these things is you write your function, whatever it is you want to run, and you write it like it's a delegate, or you just there's usually some syntactic sugar in there that lets you pass the function directly to the event without having to explicitly say it's being wrapped in a delegate. And you register it. You say, I want, when this event is fired, I want this piece of code to run, along with all the other pieces of code that may or may not have registered for that same event. This is great in user interface programming because if somebody pressed a button and you want 6 different controls to all learn that that button got pushed, they all handle the same event and they all get the same message. Okay? Now there's some limitations on this. You don't get any guarantee about what order the different delegates will be called. That's up to the event handler. It's none of your business. Because they all get called, none of them can return anything. There's nobody listening to a return value. So they all have to have null as their return value. So they can't pass values back to anybody. The event handler doesn't pay attention to what's returned from a delegate that's handling an event. So let's look at an example of how we can do that with the background worker class. You want to stay in VB this time? Pardon me? No? No. I thought all the closet. See, I got to be very careful not to stray into political incorrectness. I was thinking all the VB enthusiasts would be here tonight. Anyway, so we have this class that's introduced in .NET 2.0 called background worker. It comes from the system.component model namespace, which betrays its origins in user interface programming. But you don't have to use it with a GUI interface, and I'm not doing that here. So it has 2 different events. One's called do work and one's called run worker completed. And in Visual Basic we use the tried and true add handler keyword, which has been around since VB.1.0 I think, to say I want you to take this delegate that I've got here, again nicely written as in the form of a little mini sub that has no name. Okay, it's just sub and then some arguments and then a body and then end sub. Okay. Doesn't return anything. It really can't because it's an event handler. What it does instead is it takes what should look very familiar to everyone. Two arguments are passed into this delegate. The first one is called sender, and it's type object. The second one is called do work args. That's, I believe, called background. The class for that is background worker arguments or something like that. Anytime you see a method with something that says object sender something something arguments or something something args, that's a delegate. That's an event. That's an asynchronous event handler. Well, maybe a synchronous event handler. That's an event handler, right? And so what does this do work event handler do? It takes the argument that gets passed in and it assigns something to its result property. That's how we get the result of whatever it is we're doing into the event handler. Okay? If we didn't want to return anything, then we wouldn't assign anything to it. We'd just do something and then stop. So that's the, can't see this very well. Slide this over a little. So I'm enlarging the font. Still can't see. Yeah. All right, so that's how we do work. Then, when work is done, we register another handler that is another sub that's again takes an object sender and a different kind of argument, worker completed args, and it takes worker completed args, looks for a result property on there. That's whatever the do work handler did. We take that, we assume it's going to be a new status, and we feed it into the update status function. Okay? Now, this is a little simpler. Well, it doesn't look so simple in Visual Basic. I have to say I'm not a huge fan of the way Visual Basic handles lambdas. It's cumbersome, but then it's Visual Basic, so of course it's cumbersome. Let's try it with C#. The C# version, just to see it real quick. I'm going to leave the delegate version up and compare it to the event version. Okay, so even though it's verbose, it's still taking up a lot of lines on here. It's somewhat easier at a glance to follow what's going on. Okay, I'm registering handling, and in C# you get to use the little plus equals operator to instead of writing add handler to indicate that I'm going to handle this event. Okay, so with hopefully the same result. Yep, he's dead. Now, you can see this is sort of a prototype of what the task parallel library is going to be doing. One big limitation of it, though, is that there's nothing to stop any number of delegates from latching on to any of these events. And each delegate has no idea that there are any others on there. If you start passing the event object around from function to function, or calling it from some context where you don't know everything that might have happened to it before you get hold of it, there may be handlers already on it that you don't know about. In a case like this, where more than one handler could register to do work, and then more than one or more handlers could register to receive the results, every one of these handlers is going to get called for every single one of these. So you're going to get results that you know where they came from, but you might get other results that you don't know where they came from, because you don't know what other handlers there are attached to that event. Okay. And let's see, do I have any more? Of course there's more. So that brings us to the present day. Task parallel library. I was astonished to reading up on this to remember how old this is. They were talking about this, back in like 07, 08. I think was when the first public releases of this came out. So it's been a while. It's not as new as I remembered it being, but then this is perhaps showing you how much asynchronous programming I've done over all this time. Anyway, I got introduced in .NET 4.0, which officially got released in 2010 with Visual Studio 2010. So if you have Visual Studio 2010 or higher, you've got the task parallel library. The hot new thing on the block is the async and await keyword syntax, which is only available in .NET 4.5, which means Visual Studio 2012. And it's real nice. So if you haven't upgraded Visual Studio 2012, go tell your boss that you want to use async and await keywords in the worst possible way, and it ain't much bucks for all the benefits you're going to get. Everything works under the control of a type called a task. Okay, and I've very much avoided using the word task up to this point in the talk. Before the task parallel library, I could have called a process or an operation or even a function or a thread. I could have used the word task in a colloquial sense, and you would have understood what I meant. But I didn't want to do that because now we have a very specific thing called a task, and this is not arbitrary or random or colloquial. There's very, very precise things that tasks do, and so I'm purposefully, when I say task, I mean one of these. It's got its own namespace that's underneath system.threading. And what does it do? It does everything. It runs your asynchronous code for you. Now, the implementation of it is still using the same old stuff that we've already seen. Okay? It may very well be pulling threads out of the thread pool. It may very well be scheduling those threads using asynchronous callbacks. It may be using events and event handlers. You don't know, and you're not supposed to care. If you really do care, either because something you're writing would break, depending on how the task decided to implement it, then you probably shouldn't be using tasks. If you care because you are so hard-pressed for performance and conservation of resources that you can't afford a single scrap of overhead that you cannot account for, then you probably need to go back to system.threading. Okay? But for the vast majority of cases, thinks Microsoft to themselves, this is going to work just fine. You'll have no problem with the with the way it does things by default. And as an added bonus, if you really do have an issue with the way it does things by default, well, you can change it, sort of.